Today, I want to talk about the array method sort from the problem two-number sum, a pretty common algorithm problem on arrays. Write a function that takes in a non-empty array of distinct integers and an integer representing a target sum. If any two numbers in the input array sum up to the target sum, the function should return them in an array in any order. If no two numbers sum up to the target sum, the function should return an empty array. Note that the target sum has to be obtained by summing two different integers in the array. You can't add a single integer to itself in order to obtain the target sum. We can assume that there will be at most one pair of numbers summing up to the target sum. So here is an unsorted array and the target sum. We want to return an array that contains the two numbers that sum up to the target sum. So in this case, the numbers are -1 and 11, and they don't have to be in any particular order. There are a couple ways of solving this. The least efficient way to solve it is using double for loops, which results in a time complexity of O of n to the power 2. I won't be walking through the solutions because there's this really awesome video walkthrough by our amazing ex-fellow, Chelsea, that explains all the solutions. I will post the link down below. Please check it out. Currently, the solution using hash map is the most optimal with a time complexity of O of n and a space complexity of O of n in worst-case scenarios, due to the fact that each element in the array may need to be added to the hash map. There's another solution using pointers with the same time complexity. The idea is to move the pointers until they meet in the middle and check if the values at the left and the right indices add up to the target sum. If they do, push the values. If the current sum is less than the target sum, move the left pointer to the right. Else, move the right pointer to the left. And then we return the array. Let's run the function. It passed 11 out of 12 cases. That is because this method will only work for a sorted ascending array, because that's how we are able to compare the values between the target sum and the dynamic current sum, and determine if we need to move the right pointer to a smaller number or the left pointer to a larger number. Let's try to sort the array before we run the loop. Array.sort mutates the array, so we don't need to reassign the value. Now it only passed 9 out of 12 cases. Let's console log the array and see what it gave us. Notice 11 is before 3 in the first case. Why is that? So according to MDM, the sort method sorts the elements of an array in place and returns the sorted array. The default sort order is ascending, built upon converting the elements into strings, then comparing their sequences. So it's sorted by the string value of the elements. That makes sorting numbers inaccurate. We can actually solve this by using a comparative function, which is an optional parameter of the method. The function takes in 2 arguments and return a -0 or a positive value depending on the arguments. When comparing strings, we can use this form right here. If it returns a negative number, A goes before B. If it returns a positive number, B goes before A. If it returns 0, A and B are unchanged in their positions. When sorting numbers, we can just write the function as this, as long as it returns a -0 or positive value. So it doesn't have to be -1, 1, or 0. So let's implement that in our solution. Since we want the array to be in ascending order. So for example, if we want to compare 11 and 3, we call the comparative function. It returns a positive value of 8. Therefore, 3 will be going before 11, and it will keep comparing that way for the rest of the numbers. Now if we run the function again, it passed everything. In a V8 JavaScript engine such as Node.js and Chrome, array.sort uses either quicksort or insertion sort and has a time complexity of O of n to the power 2. So overall, if we use the sort method, it becomes less efficient in worst-case scenarios. However, sort is a very useful prototype method. You can use a comparator function to sort other data types, such as objects. An example would be to sort the object by age first, then name. by combining the two values. We implement a compare function to sort the values as strings. We run the function, and that gives us the objects in ascending order, by age first, then name. Remember, the default sort of strings is in ascending order. So if you're looking to sort in descending order, you can just call the reverse method. If we run the function, that gives us the reversed order of age, then the reversed order of name.